derive Kepler's third law, we first look at the speed of a satellite. So from the other derivation that we did and the content that we've already covered, we know that the speed of a satellite is given by this. The velocity is equal to the square root of g big M divided by the radius. But what is speed? If we go back to the original definition, it's just the distance that the object travels divided by the time taken. And in the satellite's example, it is just the 2 pi r, which is the circumference, so how far it travels around in its orbit, and capital T is the period. So if we just look at those two, that's obviously going to be equal to the velocity of the satellite as well. If we equate both sides and then I square this bit to get rid of the v squared, I end up with this. I get the big G, big M, R, and then I get a whole bunch of squared values. I can just rearrange all of this stuff, just tidy it up a little bit, and I end up with my t squared equals 4 pi squared r cubed over gm. So this is Kepler's third law. It's just derived using the velocity of a satellite, and then I take that, I square both sides once it's equated to the distance over time, the 2 pi r divided by period, and I end up with my formula. And remember, this is the fundamental aspect, that t squared is directly proportional to r cubed, and that is Kepler's third law derivation.